Hi, everybody, and welcome. This is the next in our series about all the best practices for Prisma Access. So we're going to be concentrating on routing today. We're going to talk about best practices for routing with Prisma Access. We have some routing examples, a couple of different modes we can work with, and the idea of traffic steering, which is basically exceptions to static or dynamic routing. We're going to talk about all of these things and how this affects your Prisma Access deployment. We're going to talk about all of the ideas of integrating with BGP and static routing and all of the routing meshing that we do in the background, and also talk about how you can make exceptions of that with traffic steering rules. Before we get into the routing examples, however, I think it's really important that we talk about licensing, because this makes a big difference in what options you have. So there are several different additions or licensing levels that we have: business, business premium, ZTNA, which is Zero Trust Network Architecture, and enterprise. Well, they mean different things, have different functions. The basic business license allows you to have remote networks, in other words, different offices or storefronts that have access to a remote network security processing node, an RNSPN. With business premium, we also have the idea of being able to do things like data leakage protection, and we have additional licensing for threat prevention and wildfire. But routing wise, they're the same. When we get into the mobile user solution, ZTNA, all of a sudden we have the idea of these service connections that are available. And with the enterprise license, we have everything. It's the remote networks, mobile users, all of the threat protections, and we have a lot of routing options. So many of the things we're going to be talking about today assume you have the enterprise licensing. But let's take a closer look at all of the options. So the idea of the business edition is that you can have mobile users and remote networks. So in other words, I can have users sitting at home, users at a headquarters or a branch office or whatever, that are trying to get out to the internet, get to their SaaS applications. They need access to the internet. Well, the whole idea of Prisma Access is let's not backhaul everything back to a data center and make the connection slow and all that. Let's put the security up in the cloud near the users. And that's what we're doing with Prisma Access. So we have direct access into the internet for any of your web browsing and your SaaS applications that everybody uses these days, you know, Workday and Salesforce, Office 365, and all of those things. If we add the premium edition, we get the threat protection and wildfire, which is our 0-day protection option for threats we've never seen before. And you can be protected from these based on crowdsourcing of new threats, new files, and new things people seeing. There's another licensing feature, the ZTNA, the Zero Trust Network Architecture. This is mobile users only. So no branch offices, nobody sitting in an office trying to get out to the internet. It's people sitting at home, people in the hotel room, people at a airport. It's a remote access VPN solution. This gives us the addition of service connections over here on the left-hand side that you do not get on the other two solutions, which then gives you access to a data center for services such as authentication services like Active Directory or multi-factor authentication or internal DNS servers or whatever sort of service you might need, and still gives you access to the web and to your SaaS applications and all those things you need on the internet. The Enterprise Edition gives you all of the above. These service connections that get you back to data centers when you need to. The ability for mobile users and remote network users in a branch office to be able to get out to the internet with all of the threat protections and zero-day protections, URL filtering, and all those things that we can do with Pan OS. One more additional licensing feature that is really important when it comes to interconnectivity between branch offices or remote networks and users and all of the above is the Interconnect add-on licensing, which means as a mobile user, I can connect directly to a user in a branch office without having to go out to the internet and back in. Or if I'm in a branch office at Office 1, I can talk to a user in Office 2 without having to eclipse Prisma Access, go out to the internet and come back in. So it makes it much more efficient. Some of the routing we're going to be talking about today depends on these different licenses, and especially the Interconnect license. So let's continue on. The first thing you need to know about the default routing configuration with Prisma Access at Palo Alto Networks is that internally we do dynamic routing using eBGP to connect all the different nodes, all the different peers together. So we have the ability to find the shortest, best route at that moment in time to get from point A to point B, whether it's between a couple of data centers or between a data center and a service connection or whatever the case may be. The other thing is we are regionalized. So you have the ability to have multiple service connections with different data centers in different compute regions around the world. You know, North America, Europe, Asia, South America, Japan, wherever it might be. And automatically, without you having to configure anything, if I need to reach a data center and a service connection to, say, authenticate, or to be able to reach an internal DNS server or whatever service I need to reach, I go down a service connection through a service connection CAN, a corporate access node, which is an internal connection that nobody out on the internet can reach, but I can as a user. I go to the closest one. If I got one in the United States and one in Europe, if I'm in the United States, I go to the one in the United States. If I'm sitting in Amsterdam, I go to the one in Europe. If there's an outage at one of these data centers, I go to the next closest one. There's nothing you need to configure to make this happen. This is just automatic. It is the same with mobile users. So if I'm sitting at home and I want to sign on to Global Protect, and I want to get out to the internet, and I need to, I don't know, do multi-factor authentication or Okta or LDAP or whatever the case may be. I need to reach my authentication server that's sitting there at a data center somewhere in the world. Well, I go to the closest one to me. If I have one data center in the United States and one in Europe, I go to the one in the United States. If I have two in the United States, I go to the closest one in the United States. And it's the same with remote users. So therefore, you also go to the closest corporate access node. You also get the closest service connection. There's built-in redundancy in case something goes down, and there's nothing you have to build to make this happen. This means that the traffic logs that you're used to looking at with an on-premise firewall with a bunch of different security zones, they look a little bit different when we talk about Prisma Access. And I want to look at this. So this is an example of traffic logs. And the example I'm going to give is I have users in a remote network B at a branch office on the left-hand side, making a connection through Prisma Access to remote network A on the right-hand side, and then a response coming back. So I'm going from B to A. When you look at the traffic logs, interpreting Prisma Access traffic is a bit different than it is with an on-premise firewall. Usually you look at the from zone and the to zone, and you see, oh, it's going from zone A to zone B. And you have the rule it hits, the app ID, whether it's an allow or deny or whatever. But let's take a look at how we represent this within Prisma Access. The from zone tells you where the traffic came from. So if I look at the very first line here, it says remote network connection to B. So whatever I named that IPSec tunnel from network B into Prisma Access, so object number 4 there is what I call the from zone. The to zone, in other words, where the traffic ends, in this case, network A, is either internal forwarding, inter FW, or it's going out to the internet, and the only designation to say it's going out to the internet is untrusted, or whatever you name that outside zone. So what this is telling me is I've got traffic from network B staying in Prisma Access. I'm not going out to the nasty old internet. I got an application, I got source and destination IP addresses, I got interfaces that I can add if I want to that give me tunnel IDs. It gives me a rule and a session end reason. So in this case, it's a reset from client, reset to server. If you look at the things, those are normal session end reasons. But what I want to bring your attention to is the fact that IP addresses, the source and destination IP addresses, and the tunnel numbers, which you do not assign, but Prisma Access assigns to you, become the way you determine what your destination is. This is weird and different, but very important to understand. If there are questions about any of this, After the session, we're going to have a Q&A. But understand that the from zone is what remote network, what branch office you're coming from. The destination, the to zone, is either something inside of Prisma Access, which is internal forwarding, inter-FW, or it's something to the untrusted side, whatever you named it. And you have this other information to help you diagnose what that is. All right, so let's talk about different routing modes. So first of all, what do we do by default? Well, by default, we use our Prisma Access routing infrastructure using our eBGP to get you from point A to point B, from this node to that node as fast as possible with built-in redundancy. You don't have to do a thing. And if we need to route outside of Prisma Access, then we will go down to service connection and route wherever we need to go. There's a second option, hot potato routing. So the default routing is also called cold potato. But hot potato, just like a hot potato, we want to get out of our hands. We're going to toss it to somebody else. In hot potato, we're going to hand off the routing of traffic down into your customers or your routing infrastructure. So if you have a robust BGP routing infrastructure already, we can leverage that. What we do is we go down the nearest service connection and go down into your BGP infrastructure. Let your peers tell us where to go. By default, if I've got a user in, say, the US region destined to a branch in the European region, then what I'm going to do is the traffic is going to go from the node in the US to the node in Europe and down to the branch office, down to the service connection or remote user in that office using our own routing infrastructure. Well, you or your customer may say, you know what, Palo Alto Networks, I don't need y'all to make that distinction. I want to do this. So what we would then do is immediately, as fast as we can, find the newest or nearest service connection. Let's say I'm in the US and I have a service connection in the US. You know, maybe I'm on the East Coast and the service connection on the West Coast. Perfect. I'll take that down into my data center where I have my own BGP set up, and I will forward traffic to Europe using my internal BGP peering ASs and all of that good stuff. You have the ability to choose either one. By default, we do the default routing. You can set up the hot potato routing. The final topic here is going to be traffic steering. This is interesting. So routing, the layer 3 protocol, looks at source IPs and destination IPs and says, well, I have a list of routes, and this route tells me to use this default gateway to get to that destination. And it uses only IP addresses. That's why routers and layer 3 switches are called layer 3. With traffic steering, we have the ability to create alternative paths, alternative routes, alternative ways for us to get from a source to a destination based upon things other than just source and destination IP addresses. So we have a different table, a different set of rules to set this up. And we have the ability to either use the default routes that are within Prisma Access configuration, and they can ignore any default routes that might be in data centers, on their routers and their peers and all that sort of thing. Or we can use traffic steering. Traffic steering allows us to use things such as applications and source IP addresses and user information to make decisions on which way to route traffic and which is the best way to route traffic based on this information. Well, you can't do that with native basic routing. The only thing you can do is say, well, I'm destined to this IP address. How do I get there? Traffic steering allows us to make exceptions to that. As an example, mobile users in square number 1 here on the lower right, their default path, their default route is to go straight out to the internet to get whatever they want. You assume your users sitting at home or in a hotel room or whatever need to go to Workday, or they got to read their email or whatever. It's a SaaS application. It's out on the internet. That's the way you want to go. Well, you may have some traffic that you would like to engage and to change their direction to go from point 1 when they get the mobile user SPN to route them back through a data center and out of security stack in number 2 here. So their path wants to change. So now you can define what traffic uses route number 2 here. If I need mobile users, some sort of traffic to go to headquarters and go through my security stack and go out to the internet, and instead of going straight out to the internet like I was doing in this slide, I can do this. And the way I can do this is to look at source IP information, source addresses, IP addresses, users, destination IP addresses, URLs, and URL categories. So I can say, well, if you're going to company.com, go this way. If you're going to example.com, go a different way. I can do by URL category. I can say, well, SaaS applications go this way. General internet goes the other way. I can do by service type. So port 443 goes one way, port 80 goes the other way. And if I look at destinations, I can say, I need to go through a service connection, a group of service connections, or straight to the internet. And let's talk about that for a second. Let me go backwards here. So if I want my mobile users to go to headquarters down a service connection, I can define a specific service connection they use, or maybe it's regional, or maybe I have a primary and a backup. So I can define multiple ones. And then I can make sure that traffic that's going out to the internet goes down to the headquarters and out to the internet first. Or I can say, you know what, there's more than one service connection. There's more than one headquarters or data centers that you might use. If you're in Europe, you got these choices. If you're in North America, you have these other choices. So let's do that. Or I can say, you know what, let's go straight out to the internet. So therefore, I can make routing rules to determine what needs to go down a service connection to a data center, or what needs to go down a service connection to one of many different data centers, or what needs to just go straight out to the internet, which is the default path. And this works for mobile users and remote networks. So if we kind of look at this, mobile users, they go through a mobile user security processing node, right? That's the firewall in the cloud for them. And remote network users go through a remote network SPN. And both of those, by default, go out to the internet. We do security and then clear them, and then they go to the internet. But if there are certain connections, certain types of traffic, certain users, certain applications, certain IP addresses, remember all the source and destination information we can use that need to go to in a different direction, well, we have the ability to do that. We have the ability to first send them down a service connection and then out to the internet, or say some traffic goes out to the internet and other traffic goes to a data center. And we do this by using traffic forwarding rules. And the idea of these traffic forwarding rules is we can use source addresses or users, destination IPs, URL categories, port numbers, and we can have an action to say, go in this direction, that direction. This now gives you the ability to totally shape your traffic and determine what level of security you need and what the fastest path is, and override our basic functionality, which is to give you both, but it gives you control over all of this that you did not have before. So in other words, maybe Office 365 traffic, I want to make sure goes straight out to the internet, and random internet traffic going to check my sports scores needs to go through a remote processing node. But if I'm trying to use DNS, that needs to go back to a data center where my DNS server is. So I can create traffic forwarding rules to make all of those things happen. So this is pretty cool stuff. Now, if you have any questions or any comments you'd like to make, we're going to open the floor for this. And if not, thank you for attending, and I appreciate it. But now is a great time to ask any questions you might have.